This is motion analysis of falling paper cones by Mike Paula and Kellen Pope. All the plots were made using log or pro, and the calculations were made using the data estimated from the plot graphs. So first we have the graph for the 90-degree single cone with a drop time of 1 second, displacement of about 1 meter, average velocity 2 meters per second, and average acceleration of around 4 meters per second. For most of these graphs, again, I just want to note that we do not have a saved log or pro file. We made all of the graphs separately and saved the charts as PNGs, but we did not save any of the log or pro files. So a lot of these figures are estimated by looking at the plots we have here. Next is our 90-degree double cone. This one has a slightly longer drop time of 1.2 seconds. Displacement of 0.63 meters over half the drop time. Average velocity of 1.24 meters per second and an average acceleration of 2.43 meters per second squared. The 90-degree triple cone has a even faster drop time than the 90-degree double cone, of drop time of 0.96 seconds, displacement 0.7 meters, average velocity 1.46 meters, average acceleration 3.04 meters per second squared. 90-degree quadruple cone has the fastest drop time of 0.81 seconds, the displacement of 0.65 meters at half drop time, average velocity 1.8 meters per second, average acceleration of 3.95 meters per second squared. We hypothesized that the 90-degree quadruple cones would have the fastest drop time and fastest average velocity and acceleration. Our log or pro plots for the single cones don't really reflect that, but I believe that our calculations were off using the video analysis. And again, we don't have our log or pro file saved in order for us to redo these graphs. The 150-degree single cone has drop time of 1.2 seconds, displacement of 1.18 meters per second, 1.18 meters over a half drop time, average velocity of 1.97 meters per second, and an average acceleration of 3.28 meters per second squared. The 150-degree double cone has a slightly faster drop time of 1.02 seconds, displacement 0.6 meters, average velocity of 1.18 meters, average acceleration of 2.31 meters per second squared. The 150-degree triple cone has a slightly faster drop time, 0.96 seconds, displacement of almost half a meter, 0.49, average velocity 1.2 meters per second, average acceleration of 2.13 meters per second squared. Comparing it to the first trial of the 150-degree single cone, both the double cone and the triple cone have slower average velocity and average acceleration based on the single cone. This does not line up with our hypothesis that heavier cones would drop faster. This could be due to a lot of lab errors with us setting up the lab, or possibly errors in Logger Pro with the data analysis and how we made our graphs. However, for our 150-degree quadruple cones, we have our fastest drop time of 1.74 seconds, displacement of 0.7 meters over a half drop time, and average velocity of 1.89 meters per second, and average velocity of 5.11 meters per second squared. So our quadruple cone definitely had our fastest acceleration compared to the other three trials for the 150-degree cones, and which is consistent with our hypothesis that the heavier weighted cones are going to drop faster.